Hello everyone, welcome to Scisoft Academy. Here we are empowering the education through digital content. And this is me Mallikarjuna, and today we are going to learn about the object-oriented programming concepts. So without further delay, let's get started. So these are all our today's session outlines. So we are going to learn what is meant by object-oriented programming, and we are going to see some basics around it. And we are also going to see the pillars of object-oriented programming. So let's start with the basics of object-oriented programming. So let's start with the basics of object-oriented programming. So the basic building block of object-oriented programming is the objects and classes. So what do we mean by classes and objects? So let's go with the very basic understanding of that. So if we take any of the programming languages, we'll be given with a set of primitive data types. So what do we mean by primitive data types? Primitive data types are nothing but the built-in data types that are coming along with the language library. So for example, integer, boolean, character, string, etc. So all these are actually primitive data types which we have in our programming language. So but whereas a class is a user defined data type. So what we are going to do is we are going to define our own data type which is going to do more than storing values. So a class can contain data members as well as functions or methods as well. So what do we mean by data members of a class? So data members are nothing but the variables that we can use or to store values and retrieve values inside the user defined data type or data members. A class can contain n number of data members as well as it can also contain n number of methods or functions also. So basically, so a class is not going to occupy memory. So when it is going to be in our main memory, so when we create a copy of that class, so or else we can say that we are going to instantiate that class, which means that we are going to have similar type of instances. So these instances we call it as object. So these two are the basic building blocks of object-oriented programming. So all the upcoming pillars of object-oriented programming are based on these classes and objects. So what do we mean by object? So as I explained earlier, objects are nothing but the instances of class. So class is a blueprint actually. So when we create a copy of that in a main memory for execution, those we are calling it as objects. And in objects there is a specific functionality also we can say. So let's say we have a code and we have data, and the process of binding this together is actually achieved in the object. Let's take an example of a class which has a method and which has one data members. So we will assume that the method is the code that we write actually, which performs some operations, and the data is a data member available at the class. So both are accessible in the object. So this object is going to bind the code and data together during runtime. So this is the very basic information about objects and classes. And there are a lot of object-oriented programming supported modern languages such as Java, C++, Python, etc. So all these languages are object-oriented programming supported. So let's start with the basic pillars of object-oriented programming. So there are mainly 4 pillars are present in object-oriented programming: encapsulation, abstraction, polymorphism, and inheritance. Let's deep dive into each one of them, and let's try to understand from a concept perspective. We are not going to do coding in this session. We are going to understand the basic concept behind all these pillars of object-oriented programming. So once we understood the concept, so programming is just a matter of time. We can develop any program with a given amount of time using these concepts basically. So let's start with encapsulation. What do we mean by encapsulation? So encapsulation is actually the process of wrapping the code and data together into a single unit. So what do we mean by this? So as we have already seen in the previous explanation where we were explaining the object concept, so object actually helps us to achieve this encapsulation. So through encapsulation, what we are trying to do is we are trying to bind the code and data together, which means that at runtime we'll be having access to our data members through the code or functions that we have in our hand. So here, one beauty of it is one object can interact with many other objects. The object need not have to know the other object's identity or what are all the members it contains or the member functions it has. So we doesn't need to know all of them. So we just need to know what is the return type of it and what type of data that object expects. So let's talk about some advantages of this encapsulation. So when we do encapsulation, what is the advantage that we will get? So yeah, so first thing is encapsulation can make our class read only or write only. Okay, let's talk about it. Like how do we make a class read only or write only? So what we do here is we will declare all the data members to be private. Private is an access modifier which which will not expose the data members outside of the class. So this can only be achieved. The accessing of private data members can only be achieved by adding setters and getters method, which is actually public. These methods helps us to process the private data members. Like we can able to set data and get data using those getters and setters. So this is how we can make a class read only or write only. And the second point is, since we have our own getters and setters, we can have more control over our data. Suppose if you want to filter some type of data, you want to set only marks above than 90. So in that case, you can filter it in the setter directly before setting it to actual code, whether it can be runtime or it can be in a database. So before that, we can actually have any kind of filtration, which actually provides us better control over our data. And it actually helps us to achieve the data hiding process. So if you see here, suppose if our class don't want to expose any of these getter methods, so which can have only setter methods, which means that we will not expose anything from our class. We can only set data to our class. So these kind of getters and setters and encapsulation process helps us to achieve data hiding more efficiently. And of course, it is easy for testing. We can actually write unit tests very easily for these encapsulated classes. So there are a lot of standard IDEs available which can actually generate the getters and setters methods for us. So this will help us to reduce the time for development and also helps us to write unit tests in a better manner. Yeah, that's all about encapsulation. I hope we made it clear for you. So let's talk about abstraction a little bit. So what do we mean by abstraction? So abstraction is actually a process of hiding the internal details from the user. So we will show only what the user needs to show, or one. So basically, what we can take in terms of programming is, so basically what we will show to user is what the object does. We will not show the user how it is done. Okay, so let's take an example here. Let's say we have two users, user 1 and user 2. So he or she wants to send a message to user 1 to user 2, which means that what he will do, he'll just take his mobile phone and he'll write the message and he'll hit the send button. So, and immediately within a few seconds, the second user is going to get the message. So here is our basic abstraction example. So the user does not know what is the backend process that is happening. Let's say if you take a note on the backend process overall. So when the user types a message and hitting the send button, So what will happen is the data is going to be encrypted using a different keys, and it's going to be transmitted to the backend server, and the backend transmitted server is going to run some business logic to identify the receiver, and it's going to be sent to the nearest ground station server. Then from there it's going to be redirected to the receiver. So all these background processes are not needed for the user. The user only needs to know what the higher level APIs are, or how he can interfere with the user interface. So that's all he has to know. So this is the basics of abstraction. So just to revise, abstraction is a process of hiding the internal details from the user. So we will only show what the user needs to show or what has to be shown. So I hope we made it clear for you. Let's go ahead with the next topic, polymorphism. So what do we mean by polymorphism actually? So the word itself is actually derived from a Greek words. So poly means many, morph means, so basically the meaning of this word is many forms. So basically we can achieve the polymorphism through two ways. One is runtime polymorphism and compile time polymorphism. So here we will talk about the compile time polymorphism. So compile time polymorphism can be achieved with method overloading or operator overloading, whereas our runtime polymorphism is going to be achieved through inheritance, or we can also say method overriding. So in this slide, we are going to talk about the compile time polymorphism. So what do we mean by compile time polymorphism? Let's say the relations between, let's say we have two functions with us. Let's say we have a function add, which takes two integer parameters and gives us the result of, gives us the addition result of them. So we can actually declare a method in the same name in the same class, let's say add, and we can actually change the parameters. We can actually give two strings, and the result, we can just make the result to be concatenated strings of that. So basically what we are achieving here is we have the same name of the method, but the parameter type is different. Even the parameter count is same, but the parameter type is different. So by this actually we are achieving the method overloading. So during this, so this method overload is going to be detected at the compile time itself. Let's say you have an error, you have the same method signature and also the parameter signatures, and you are going to get an error during the compile time itself. So your code will not compile unless you modify it properly. So this is why we call it as compile time polymorphism. On the other hand, when we talk about runtime polymorphism will not give you any error during compilation of the code, whereas it is going to throw some error during the runtime of the process, which means that when the program is executed and it is running in the main memory, during that time we are going to get an error from the process. So this runtime polymorphism, to explain this runtime polymorphism, we have to understand the concept of inheritance first. So let's talk about the inheritance in the next slide, and we'll also see what is method overriding in the same system. So inheritance. So what do we mean by inheritance? So let's take an example here to understand the concept of inheritance more. In this picture, if you see, so what do we mean by this is the child is actually inheriting some properties from the parents. Let's like hair color or skin color or some behavioral properties. So these kinds of properties are inherited from the parents, which means that which is going to be similar as their parents, and the child is going to have his or her own behavior. So this is what the basics of inheritance. So we'll be having the base. So yeah, let's talk in terms of classes now. So let's say we have a class created, and we parents class. Let's say we have a parents class created, and we have a child class which is actually inheriting from the parent class. So in that case, the parent class is called as a base class, and the child class is called as a derived class. Let's say the parents class is having two methods. Let's say read and write. So the child class is also going to have access to those methods, and if the child class wants wants to override that method, he can. So basically, we can actually write the same method. Let's say we are writing the same read method inside child class also, so that during runtime it will be applied to the child class. So this is what we call it as method overriding during runtime. So we will talk about this with code examples in the later upcoming sessions. So this is the overall concept of inheritance. So basically inheriting the properties from parents, and the child is having its own properties and behaviors. So this is all about today's session. So do let us know if you have any questions in the comment section. Thank you for watching this video, guys. See you in the next one.